Perfect. So we're continuing 2.2. I guess this is continuing 2.2. That's kind of cool. I'm going to call this part B. So make sure you're following along as we need it. So again, I'm going to continue on with approximating the derivative by using points on either side. So as I'm looking at 1, again, you have the option of doing the slope between 0 and 1, 1 and 4, but it's actually best if you do the opposite 2, like on either side. I guess I shouldn't say opposite. And you just use your slope formula. Well, y minus y, so 0 minus 1, y minus y over 4 minus 0, the x-coordinates that we're using to approximate. So we get negative 1/4. So that's my clue that this is going to be a decreasing function. And as we approximate the equation of the tangent line, we're going to say y equals negative 1/4, and then x minus the x-coordinate we're talking about, and then the y-coordinate at that point is negative 3. Again, this is just point slope form. Maybe I should remind you, traditionally point slope form is y minus y1 equals m, x minus x1, except a lot of math people don't like writing y minus. They want to write y equals. So to move that to the other side, you just add it over. So it is point slope form, you can believe me. So as we look at x equals 4, more of the same thing. The derivative at x equals 4 is approximately, we're going to use the values on either side of 4. So I'm going to do negative 7 minus negative 3 over 6 minus 1. By the way, you don't have to use the values I give you, but I'm seeing that I get negative 4 over 5. So we have another decreasing function. Just because it's a negative slope, in case you forgot from the previous video. And then plus 0, but you don't have to write that. So just one more to go. We're going to approximate f prime of 6. And we're just going to estimate. It's impossible by looking at a table to get the exact slope at that point, but we can use points on either side. So I'm going to do y minus y over x minus x. I believe I have the right values, 2 minus 0, 10 minus 4, and then reduce that, 2 over 6 reduces to 1/3. So at least based off of that secant line, now it is a secant line, even though I haven't really mentioned that before, because we're connecting points in between, like on either side. That's technically called a secant line. So your slope, it's increasing because the derivative is positive, x minus the x-coordinate, and I already forgot what the y-coordinate was, negative 7, so minus 7. So pause the video if you need to, write down anything you need, and then we're going to move on to the next part of this lesson. And in the next part, now we're looking at a graph, all right? And with this graph, now we can, so this is the graph of g of x, it's written in the directions. It's asking you where the derivative is negative. Well, let's think about it. What does it mean for the derivative to be negative? Well, that means, well, this is kind of your reasoning, so I might as well write it here. G of x is decreasing. So you know how in the first video I said make sure you give a reason for your answers. You give your reason based off of what they give you. So since they give you the g of x function, make sure that's part of your reason. So as we look at your reason now, where is the function decreasing? The first time it's at negative 4 until we get to negative 2. So I'm going to use brackets. There's a reason why I'm using brackets. If you decide to use parentheses, because I know sometimes I do that in pre-calculus, I will accept it. And just so you know, on the AP test, they will fix the direction. So if this is multiple choice, they'll make it clear what kind of answer they're looking for. So don't be, I guess, bothered if you think this should be parentheses instead of brackets. But then don't forget it's also decreasing for the x value bigger than 1. So from 1 until infinity. And remember, we always use parentheses with infinity. So as we look in the next one, I mean, just switch colors just to change it. Where is the derivative positive? Remember, if the derivative is positive, that means the function g of x needs to be increasing. Well, where is g of x increasing? That would be from negative infinity to negative 4, and then from negative 2 to 1. Now, where is the derivative equal to 0? And that was my clue from the first video, is we're looking for horizontal tangents. You know, maybe you might even mention that we have relative mins and maxes. I guess having those on relative min or relative max. That's what we're looking for there. So where does that happen? At x equals negative 4, negative 2, and 1. If anybody's curious about why you can use brackets instead of parentheses, it's technically the definition of increasing is where the function, you know, is either at or above the next value, and that's why we use brackets with it. I don't always agree with that reasoning, but that is a definition, so this is technically correct. I guess I should also clarify that I should mention that g of x has a relative min or max. Okay, you want to be specific when you're giving your reason. We have one more definition to explain moving forward. So there's a lot of definitions. Is a normal line. All right, so let's investigate. So picture to the right, we have this function defined here. They ask you to draw the tangent line at x equals 1. So x equals 1 is right here. And it looks like that slope is about negative 2. I don't know if that's exactly correct. But we're just going to estimate the value. And I would say, based off of what we have, it's about negative 2. So if we asked you to find the equation of the tangent line, well then we would write it the way we want. Y equals that slope that we approximated, x minus the x coordinate. Oh, we don't know the y coordinate. Well, there's two options. Go back up here and plug in 1 in for x. So 1 plus 1 is 2 squared is 4. Negative 1/2 of that is negative 2 plus 4 is 2. Or, the easy way, just look at the graph. Graph is right here at 1, 2. So clearly the y coordinate's that. Now here's the tangent. Here's the normal line. The normal line is perpendicular to the tangent line. So what that means is instead of having a slope of negative 2, that slope is a slope of 1/2. Something like that. And what it does, and I should put arrowheads on my orange equation as well. Let's not try. Why did I do that? There we go. Okay, back to this color. Is it makes a right angle. Why does it do that? A right angle at that point. And we learned some cool things with this, sort of beyond the scope of calculus. But right now you should understand that a normal line is perpendicular to a tangent line. So we drew it, and then writing the equation is as easy as the first one. Well, the perpendicular means the slope of a perpendicular is the opposite reciprocal. So it's 1/2. Opposite of negative is positive. The reciprocal of 2 is 1/2. So we have that. Now, if you want to, feel free to distribute and simplify, but this is all I ask you to do for right now. So we can ask a few more questions. Now notice, this is always stump students. This is the graph of the derivative. So this is h prime of x. So now we can answer these questions in a way different context. So where is the original function h of x increasing? So might be worthwhile to mention, okay, well, if h of x is increasing, that means the derivative must be positive. Okay, and you can write it this way, or you can write it, h of x is positive. Now, I think you'd be fine if you put an or equal to there, based off of everything. But where is this function positive? We can say from -2 until we get to 1. And again, the way that the AP calculus tests are written, it'll be clear, that they are looking for this. So you could say positive or equal to 0. Actually, let's stay away from writing or equal to 0 because of the way some of the notation is. And then or, where else is the function above the x-axis? It is from 3 to infinity. Something like that. So let's talk about where the function is decreasing. All right, well, if we're saying that the function is decreasing, that means the derivative needs to be less than 0. Or you can say the derivative is negative. So as we're looking at that, maybe what we need to just say is from negative infinity to -2, and then from 1 to 3. Why? This curve is below the x-axis from here to here. So let's talk about what needs to happen in order to have a relative maximum. All right, and I'm just going to change colors completely. Let's just draw a maximum real quick. Well, in order to have a maximum, it has to be an increasing function to a decreasing. But we can't just say increasing to decreasing because the graph gives us the derivative. So what does that mean in terms of the derivative? It has to change from what to what? Well, if it's the function is increasing, then the derivative must go from a positive to a negative. So where on the graph do we go from a positive to a negative? Right here, positive to a negative, so at x equals 1. Any other points? No. Same thing with a minimum. Draw a minimum real quick. It goes from decreasing to increasing, so that means the derivative changes from negative to positive. Be specific. Use the clues that are given to you. So where does that happen? A negative below the axis to above is at -2, and below to above is at 3. So x equals -2 and 3. A couple more problems, and then you're ready for the homework. So they have to give you a few clues. So like maybe it's worthwhile to writing the equation, that it's x plus your x coordinate, because we're writing the equation of the tangent line. And then they tell you the y coordinate's 1/2, so just write plus 1/2. What you don't know is what's h prime of -1. Well, we can figure that out by looking at the graph. Matter of fact, it tells you when h prime is -1, we get a y value of 5. So that just told me that the slope of the tangent line is 5 right there. Same thing with this bottom one. I know I'm going through this really quickly, but it might be worthwhile to just write x minus 2 first, and then minus 3. That's using this clue. Now notice it's asking for the normal line now. So be careful because the tangent line at 2 is -2. So h prime of 2 is -2. But remember, the normal line is perpendicular, so opposite reciprocal. Opposite is positive, reciprocal of 2 is 1/2, and you should be ready for the homework now on the next page.